Dear students, we can start our first chapter from the physics section. See, before going to the chapter, I would like to introduce our syllabus. There are 10 main branches of physics that you are dealing with in this year. The first two chapters comes under the static electricity. So, first two chapters comes under the first branch of physics, that is static electricity. Then we will move to current electricity, then to magnetism and electromagnetic induction, and we will go to other branches. So, we are moving to the first branch of physics. And first, our chapter name is electric charges and fields. See, we are going to introduce our new branch, that is electrostatics or static electricity. Electrostatics or static electricity is the branch of physics that deals with the forces, the study of forces, potentials and all regarding the charges at rest. Static means the charges at rest. Okay, so in these first two chapters, we will discuss only about the cases of the forces, potential, the electric fields produced by the charges at rest. Static means the charges at rest. Okay, so first I would like to tell you what I mean by charge. Charge is a property of a body by virtue of which it can attract or exert the electrostatic force on other objects. Then you have studied the definition of electrostatic force. What do you mean by electrostatic force? The force exerted by a charged body on charged or uncharged body is called electrostatic force. That means charged body can exert a force on uncharged or charged body. This force is known as electrostatic force. So here we are dealing with the charges. What you have to study, first one is the unit of charge. What is the unit of charge? In 10th standard you have studied the unit of charge. Charge is represented by small letter q or capital Q. The SI unit of charge is coulomb. It is represented by capital C. That's the first point. Now we can move to the properties of charges. This is the first topic comes under this chapter, and the previous sessions you have studied all of the things we have studied in the previous classes. There are two types of charges, positive and negative charges. Okay, then a positive charge attract a negative charge. That means like charges repel each other and unlike charges attract each other. So the first property of charges is like charges repel each other and unlike charges attract each other. What do you mean by that? A positive charge attracts a negative charge and vice versa. And positive and positive charges repel each other, as well as negative and negative charges repel each other. The second one is charge is conserved. That is, the total charge on a body is conserved. We have studied the conservation of energy. How we can define this property? See, the charge can neither be created nor be destroyed. It can only be transferred from one body to another. That's the definition of, that's the meaning of second property. That is, charge is conserved. What do you mean by charge is conserved? Charges can neither be created nor be destroyed. Okay, but it can only be transferred from one body to another. It can transfer from one body to another, but we cannot create or destroy the charge. The second property is the charge is quantized. What do you mean by charge is quantized? The quantization of charge means the net charge on a body is the integral multiple of the smallest possible charge. Which is the smallest possible charge? The smallest possible charge in the current universe is electron, charge of electron. So it is represented by E. Then quantized means the net charge on a body is the integral multiple. The integral multiple of smallest possible charge, that is E. Then what do you mean by integral multiple? N can take the values 1, 2, 3, 4, 5 like that. That is the whole numbers only. It cannot take the values 1.5 or fractional values. So this is the meaning of quantization. And all of you know that the charge of electron is represented by small letter e. The electron cannot take the values of half, 3 and half like that. So it can only take 1, 2, 3, 4, 5 like that, isn't it? So the net charge on the body is the integral multiple of electron, charge of electron. That's the meaning of quantized. Okay. Now we can move to the next property, that is additivity of charges. So there are n number of charges. Then how will you calculate the total number of charges? You have to just find the sum of the individual charges. So additivity of charges mean the net charge from the body is the algebraic sum of the individual charges. Suppose there are n number of charges, it can be represented by small letter q, q1, q2, q3, etc. to qn. Okay, there are n number of charges. Then how will you find the total charge of the body? Then you have to find the algebraic sum of the individual charges. So it can be replaced by Q equal to, that is net charge equal to Q equal to sigma I equal to 1, 2 and Q. What do you mean by this one? In the place of I, first you have to put 1, then 2, up to n you have to put. For example, there are 10 number of charges. How do you write sigma I equal to 1 to 10? Instead of n, you have to write 10. Okay, then put 1, 2, 3 and just add. Then you will get the total number of charges. So we have completed that topic. Now we can move to the next topic. That one you have studied in the 8th standard. How will you test whether a body is charged or not? The simple device which is used to test whether the given object charged or not is the Golgi electroscope. How to make the Golgi electroscope is mentioned in your textbook, and you have studied the same one in the 8th standard also. Just recall that one. Now, the other topic is also familiar to you, the conductors and insulators. How we can classify the conductors and insulators? The material which allow the electric charges to flow through them are called conductors. See, here we never use the term electric current. The reason is because the electric current means flow of charges. That is comes under another branch of physics. That is in third chapter, current electricity. So we won't use the term electric current in the first two chapters. Similarly, what do you insulators? The material which do not allow the flow of charges through them, electric charges through them are called insulators. Now, we have studied that charge is constant. That means you cannot create the charge or you cannot destroy the charge. We can transfer the charge from one body to another. Then we can see what are the different methods in order to produce the charge. Actually, it's not producing, we are transferring the charge from one body to another. There are three methods in order to produce the charges on a surface of the body. The first one is friction. The electricity formed by friction is known as frictional electricity. The second one is electrostatic conduction, and the third one is electrostatic induction. There are three methods in order to produce the charges on the surface of a material or body. They are friction, conduction and induction. Okay, then here you have to study only about electrostatic induction. So I will briefly explain what I mean by electrostatic induction. Now we can see what you mean by friction and conduction, how you can generate electricity by friction. First case, just take two objects, rub each other. Then what will happen? When we rub two bodies each other, then the generation of charges takes place. Let's see how we can generate charges on the surface of the bodies by friction. Friction means just rubbing each other. Okay. Then we have done so many experiments in the 8th standard. Rub your hair with a scale and then keep the scale near the paper board, then it will attract. Okay, then what do you mean by friction and electricity? When you rub two objects each other, one object becomes positively charged and other object becomes negatively charged due to the transfer of charges, the transfer of electrons. Okay, the body which loses the electron becomes positively charged and the body which gains the electrons become negatively charged. Okay, for example, there are two bodies A and B. You are rubbing A and B together. Then both the objects will acquire charges. First they were neutral. Okay, neutral means the equal number of positive and negative charges. Suppose when you rub A and B each other, if one electron is transferred from A to B, A becomes positively charged and B becomes negatively charged. That means the body which loses electron becomes positively charged and the body which gains the electron which accepts the electron becomes negatively charged. Is it clear? Then what do you mean by conduction? See, we need two charged bodies or one charged body. First case, a charged body and an uncharged body. This body has plenty of charges. For example, 5 coulomb. Then bring the second body near to the close to the first, keep it touch. Then what will happen? When we bring the second body to the first body, then charges start flowing from the charged body to uncharged body till both the charges become equal. Okay. For example, 10 coulomb charges are here for A. Then when you bring the uncharged body B near to the, keep in touch with the first body A, then the charges start flowing from the charged body to the uncharged body until the charges become equal on the both bodies. Is it clear? Then this is one example. Thereby you can charge an uncharged body using a charged body. Similarly, consider two bodies A and B. One has charges 10 coulomb, other has charges 8 coulomb. Here both are charged bodies, but the magnitude of charges on them are different. Then bring these two bodies close or connect the bodies together. Then what will happen? The charges will flow from the body which has more charge, more magnitude than the other body until the charges become equal. So one charge here, two charges are excessive, then the second body, then one charge will move to this one electron will move, then here become 9 coulomb, here also become 9 coulomb. So the charges flows from highly charged body to the lowly charged body until they become equal, until the net charge become equal. It's similar to the cases of water. Take two beakers of water, one has large amount of, a little bit more amount of water, and another has 2 amount of water. Just connect these to the bridge, then the water will flow from the first beaker to the second beaker until the water level on both beakers becomes similar. This is the same case. Now we can move to the third one, electrostatic induction. Here you need not to study much about the frictional electricity and electrostatic conduction. Now we can move to the next topic, electrostatic induction. When a charged body is placed near an uncharged body, the opposite kind of charges get accumulated on the nearer surface of the uncharged body, and same kind of charges get accumulated on the farther end of the surface of the uncharged body. That's the definition of electrostatic induction. I will explain the figure, that will be easy for you to catch the concept. See, consider a glass wood which has positive charge. So this is our charged body. This one is our charged body. What is the charge of this body? Positive charge. Here there is one neutral metallic sphere. So neutral metallic sphere means neutral body means equal number of positive and equal number of negative charges are there, isn't it? Suppose there are 10 electrons and 10 protons. Then what is the net charge? Plus 10 plus minus 10. Then the total charge will be 0. This is how the way you can call it a neutral body. Then when you bring a charged body near to an uncharged body, very close to the uncharged body, there is no direct contact. And in the case of conduction, direct contact must be there. That's the meaning of conduction. But here, actually, the charged body is not need to be in contact with the uncharged body. Then, when you bring the positive charges near the uncharged body, then here we know that equal number of positive and negative charges are there. Positive charge will attract negative charge towards it. Then the negative charges of this body get attracted towards the positive charge. That is the charged body. And due to the Coulombic repulsion, we know that same charges repel each other. Due to the Coulombic repulsion, all the positive charges will move towards the farthest end. So here, this is the farthest end, and here is the nearer end. So this opposite kind of when we bring a charged body near to an uncharged body, the same opposite kind of charges get accumulated on the near surface of the uncharged body, and same kind of charges get accumulated on the farthest end of uncharged body. Is it clear? So the charges formed through this way is known as induced charges. The charges thus formed due to the electrostatic induction are called induced charges. See, now two examples are given. How we can, in the first case I will explain here, then the second one you have to do yourself. How you can charge a body negatively. That's our question. How will you charge a body negatively by electrostatic induction? For that purpose, we need a neutral metallic sphere. It is placed on an insulating stand. Why we are placing this body on an insulating stand? We are using a conductor. We are placing this stand on the ground, isn't it? Then the charges will flow from the body to the earth. That is known as earthing. What do you mean by earthing? The transferring of charges from a charged body to earth is known as earthing. So there is a high chance when it accumulates the charges, it will directly move to the earth. In order to stop that, we have to place this uncharged body, that is neutral body, on an insulator stand. Okay. If you want to charge this uncharged body negatively, the charged body must contain opposite kind of charge. Since if you want to charge this metallic sphere negatively, what we have to do? We have to bring a positively charged rod. Okay, we have to bring a positively charged body near to the neutral body. So I am bringing a positively charged body near to that because our aim is to charge this metallic sphere negatively. So we are bringing a positively charged rod near to the neutral body. So at first there is a distance large distance between the charged body and the neutral body. So no changes will happen to this neutral body. Suppose I am bringing this positively charged rod very near to the neutral body, neutral metal shell. Then you can see that due to the Coulombic attraction, negative charges of the body will get accumulated to the near surface of the metallic shell. And due to the Coulombic repulsion, positive charges will get accumulated on the farthest end. See, now the positive and negative charges got separated on the metallic sphere. But we need to charge body negatively only. So what we have to do? We have to remove the positive charges from this metallic shell. Keeping this charged rod very near to the shell, you have to earth. So what will be the situation? Plus and minus charges will be there. We have to earth the farthest end. This is the signal for earthing. Okay. Then when you earth means the transferring of charges from charged body to the earth. Then earth has a tendency, capacity to send as well as receive large amount of charges. Since the positive charges are there, if you connect if you earth this end, then all the positive charges will move towards the earth. Okay. Then these negative charges are very far away from this end. Then the negative charges will remain here, but the positive charges will move towards the earth. Then after earth, what will remain? The negative charges will remain here. That is because of the Coulombic attraction. The negative charges will remain here. See here, now the charge on this metallic shell is negative only. But we have to distribute these negative charges equally. All the negative charges are accumulated on the near end. So what do we have to do? We have to bring it back, bring the positively charged body far away from this one. So this electrostatic force can only attract up to a certain limit. If you remove this charged body, then these charges get equally distributed over the metallic shell. Thereby you can charge. Now the charge of the metallic shell becomes negative. Similarly, we can charge this body positively. So what we have to do? We have to bring an opposite charged body, that is negatively charged. Glass rod is brought near the metal shell. See here, equal number of positive and negative charges are there. Then when you bring the negatively charged rod near to the neutral body, the positive charges will get attracted by this negatively charged body. Then all the positive charges will accumulate on this nearer end, and the negative charges will move to the opposite end due to the Coulombic repulsion. Then at the farther end, then all these negative charges will move towards the earth. Then what will remain? Only the positive charges will remain. Then remove the discharge body away from the metallic shell. Then positive charges will get accumulated uniformly on the metal surface. This is how the way you have to charge body positively as well as negatively. Next topic is Coulomb's law. See, the Coulomb's law gives the magnitude of the force of attraction repulsion between two charges. Here we are considering about the point charges only. Consider two point charges Q1 and Q2. The distance between the centers of these two charges can be taken as r. Then now we will find what will be the magnitude of force of attraction or repulsion between these two charges. Here, if two charges are of same kind, then the Coulombic force or electrostatic force becomes repulsive. If two charges are of opposite kind, then the force becomes attractive. Okay, now we can state Coulomb's law as the force of attraction or repulsion between two charges is directly proportional to the product of magnitude of the individual charges, and then it is inversely proportional to the square of the distance between the two charges. So I will repeat, the force of attraction or repulsion between two charges is directly proportional to the product of magnitude of the two charges and inversely proportional to the square of the distance between the two charges. So we can combine these proportionality relations in a single step. Then F directly proportional to Q1 Q2 divided by R square. F directly proportional to Q1 Q2 divided by R square. So we have to multiply. When we change the proportionality sign into an equal sign, then you have to multiply the right side with a constant. So what we can write? F equal to a constant into Q1 Q2 divided by R square. After doing so many experiments, the scientists introduced that constant as F equal to 1 by 4 pi epsilon into Q1 Q2 divided by R square. Here the new term, the new symbol epsilon is called the permittivity of the medium. The permittivity of a medium called epsilon determine the electric force between the two charges placed in that medium. What do you mean by permittivity of a medium? Permittivity of a medium is a property of that medium which determines the electric force between two charges placed in that medium. See here, we can replace this epsilon by epsilon 0. The reason is epsilon, new term and introducing new term epsilon r, that is relative permittivity. Relative permittivity means the permittivity of a medium divided by permittivity of free space or vacuum. This is epsilon r. It's also known as dielectric constant. Relative permittivity of a medium is the ratio of permittivity of that medium to the permittivity of the free space or vacuum. So, in normal case, what we can write epsilon can be written as permittivity of the free space can be written as epsilon 0. Then epsilon, the permittivity of medium, epsilon can be written as epsilon 0 into epsilon r. In the case of for the case of air, epsilon r equal 1. So we can replace this equation f equal to 1 by 4 pi epsilon Q1 Q2 divided by r square can be written as 1 by 4 pi epsilon 0. Epsilon can be written as epsilon 0 into epsilon r into Q1 Q2 divided by r square. Here, in the case of air, epsilon r equal to 0. We are considering the permittivity of air is same as permittivity of a vacuum or free space. So, if you take the ratio of relative permittivity of air, the numerator and denominator will be same. Then you will get 1, isn't it? So, in the case of air, permittivity, relative permittivity of air is 1. So, we can replace this one. Then we will get the equation F equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. Thank you.